Welcome back, students. In my last video I have solved one problem number 4.1 for you. Now this video is related to problem number 4.2. You can come over to the sheet. The problem number is 4.2. Reference number from the primary is 2. Drawing number is 15. Now in this problem only description is given, unlike the last problem. In the last problem you were given the front view of the hexagonal prism and the cutting planes as well. Here the cutting planes are not shown in any of the views or any of the figures, but you have to draw the cutting plane as per the description given here. The problem is like this: a square prism of base side 30 mm and axis length 60 mm is resting on HP on its base with all its vertical faces equally inclined to VP. So you have to draw a square with the sides inclined at 45 degrees to XY line. That is the meaning. Equally inclined to VP means. It is cut by an inclined plane 60 degrees to HP and perpendicular to VP. This is what I was mentioning. This is the only type of cutting plane that you have in your syllabus, though there are many. The only plane that you have in syllabus is plane inclined to HP and perpendicular to VP. Sometimes this perpendicular to VP is also not mentioned. Even if it is not mentioned, it is understood. It may be just given that the plane is inclined at 60 degrees to HP. But this is also understood even if it is not given. So the cutting plane is inclined at 60 degrees to HP, and then you will be given the location where it is passing through. It is passing through a point on its axis at a distance of 15 mm from the top face. So the location is given to you. You have to draw the cutting plane on your own. And you will draw it as a line in its front view. Draw the development of the lower portion of the prism. That means the upper portion will be removed, and then you are asked to draw the development for the bottom portion of the prism. Okay. So let us start by drawing the orthographic projection of the square prism first. I will draw the XY line. Now let us draw with a square in the top view. It is resting with its base on HP. So all the problems, in fact, in development of surfaces, the base is on HP. Okay, there is no other position. So all the problems we will start by drawing the top view only. But here all the vertical faces are equally inclined to VP. So we will draw a square of 30 mm side with 45 degrees inclined to XY. This is inclined at 45 equal to 30 mm. This is also inclined at 45. With these two edges you have to complete the square. So this is inclined at 45. This is also inclined at 45, and the dimension is 30. This is a prism, so each corner will be named by 2 points. So as I said earlier, we will start with this as AA1. This is BB1, CC1, DD1, and this is the axis OO1. You can mention it is square 30. Okay. Let us draw the front view now. The height is given as 60. So I am drawing the projections up to XY line. As I mentioned earlier, the front view will be drawn light, okay, initially. The height is given as 60, so this will be equal to 60. This is 30, so double that. I am drawing using light lines. Then complete the top face. This height has to be 60. Now let us name the points in the front view. This is A dash and A1 dash. This is B dash, D dash, C dash, B1 dash, D1 dash, C1 dash, also O dash, O1 dash. So here you have three edges, one behind the other. BB1 is visible, OO1 is axis, and behind that you have DD1 which is invisible. Okay, before we draw the section plane or cutting plane, let us draw the development for the entire square prism. Just extend this line. Start with the longer edge AA1. Now the longer edge from AA1 to BB1, the distance is 30. So mark 30, then 60, 90, 120. There are four edges. Okay. So this length will be from here to here, it is 120. This is 120, and you can draw parallel lines, but make sure all the lines are thin lines. So call the longer edges B, B1, C, C1, D, D1, and finally AA1 once again. Okay, so AA1 is repeated. Each of these base edges is 30 mm long. Yes. So this will give you development for the square prism, entire square prism. Now let us see where the cutting plane is. It's given that it is cut by an inclined plane 60 degrees to HP, 60 degrees to horizontal, perpendicular to VP, passing through a point on its axis at a distance of 15 mm from the top face. This is the axis. So from the top face you mark a point 15 mm. 15 mm means 1/4 of this. This height is 60, so 15. So you should mark this distance as 15. So passing through that you have to draw the cutting plane, and that should be inclined at 60 degrees to horizontal. Okay, this angle should be 60. This plane is inclined to HP and perpendicular to VP, so it appears to be a line in the front view. Now this is the portion to be retained. Now this portion I will make dark, whatever is the retained portion. Yes. So you are asked to draw the development only for the bottom portion. In other words, this portion to be removed. This is the portion to be removed. Now, as usual, let us name the section points. Once again, what is the definition of section points? It's a point where the cutting plane cuts either the longer edge or the base edge. Okay, let me start from this end, 1 dash. So point 1 is on the longer edge AA1. Next, come here. You have three edges in fact there. One is BB1, the other is axis, and the last one is DD1. Axis we do not name any point, but we have to name the points on both the longer edges BB1 and DD1. Among these two, BB1 is visible, DD1 is invisible. You have put them in brackets. So I'll start with 2 dash, 2 on BB1. Then move ahead, you come here. Yes, this is in fact cutting the base itself. When it is the base, you have 4 base edges as you see in the top view. So you don't know which base edge is it cutting. There are 4 base edges at the top face, AB, BC, CD and DA. And all the 4 base edges put together appears to be a line in the front view. So if you look at this location, you are not able to identify, or you are not able to decide which base edges is it cutting. In that case, what you do is, from this point you just project down. When you project down, it will be cutting the base edges at two locations. Okay. So it is, because it is the top face, it is BC and CD. It is cutting two base edges, BC and CD. Okay. Of that, you can see BC, it is a visible edge. D is in brackets, CD is behind, so that is invisible edge. So you will mark 0.3 on BC and 0.4 on CD. CD is invisible. Okay. So you mark 3 dash here and 4 dash in brackets. Okay. So when I write here 0.3, I will write on BC, and 0.4 in brackets, it is on CD. You can see here 0.3 is on BC, 0.4 is on CD. So whenever it cuts a base, make it a point that the two section points have to be named. I repeat once again, whenever the cutting plane cuts a base, it has to be, the section point has to be named as 2 points. 2 points correspond to two different base edges. So here 0.3 is on BC, 0.4 is on CD. Done. Now come back. Come back, you have to retrace your path back. You are coming along the same plane back. Now 5 dash, 5 is on DD1. DD1 is an invisible edge. So 5 is on DD1. That's it. You don't have any more edges left. Okay. So totally there are 5 section points. Now let us transfer these section points onto the development. Let us start with 1. 1 is on AA1. Draw a line parallel to the base. So here is 1 and there is one more here, AA1, 1. Similarly 2 and 5. Where is 2? 2 is on BB1, 5 is on DD1. 2 is on BB1, 5 is on DD1. Next comes 3 and 4. For 3 and 4, if you draw a line like this, you will not be able to identify where they are. So come to the top view. Okay. Now this is the position of 3. You can mark this distance. You can measure this distance B to 3. Let us say this distance is some x. You can measure with scale. Let us say it is x, not scale, compass. So mark this distance from B on BC. This is the edge BC. So from B, you will mark 0.3 here. So this distance is also x. That's how you mark 0.3. Similarly 4. 4 is on CD. You have CD here. And this is the distance of 0.4 from C. Let us say this distance is some y. Mark this distance y from C. This is 4. Let us say this distance has to be y. That's it. You just connect the points using straight lines since it is a prism. 1 to 2, 2 to 3, 3 to 4, 4 to 5, and then 5 to 1. Okay. Now you are asked to draw the development for this portion, the entire portion. So you have to include this as well. Whatever is required you have to show as dark. And wherever the sheet has to be folded, you need to fold it along the longer edges. So even those lines will be made dark. So these are the lines along which you fold the sheet metal. And whatever is the development, you should name like this. That's very important. So you are going to cut the sheet along this boundary, okay, and then fold to get this lateral surface. So this is a waste piece. This is also will be a waste piece that will be shown light. This is in fact a simple problem compared to the last one. You have only 5 section points. Take a look at it. We'll move to the next problem. We'll come back after taking a short break.